In this lesson, we are going to derive the law of sines and use it to complete an oblique triangle. Remember from our lesson on right triangle trigonometry that to complete a triangle means to find all of the missing angle measures and the lengths of all of the missing sides. What is an oblique triangle? An oblique triangle is any triangle that is not a right triangle. We have a method for completing a right triangle, but how do we complete an oblique triangle? First, let's review our trigonometric ratios. SOHCAHTOA is a mnemonic device that helps us remember our trig ratios. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Since the trig ratios we have learned use hypotenuse, we can only use them for right triangles because the hypotenuse is defined as the longest side of a right triangle opposite the right angle. We can use our right triangle trigonometry to help us derive the law of sines. Since an oblique triangle has no right angle, we need to drop an altitude in our triangle to form two right angles, and then we can use our right triangle trigonometry to find the missing parts of the oblique triangle. Sine of b equals h over c, which means that h equals c sine of b. Sine of c equals h over b, which means that h equals b sine of c. By substitution, we get that c sine b equals b sine c. With a bit of algebra, we can simplify this to say that sine of b over b is equal to sine of c over c, which leads to the law of sines. The law of sines states that if ABC is a triangle with sides A, B, and C, then A over the sine of A equals B over the sine of B equals C over the sine of C. This holds true for acute triangles and obtuse triangles. Let's look at an example. In our example, we are given that angle A measures 62 degrees, angle B equals 53 degrees, and side C equals 5 units. We can use the fact that the angles of a triangle add up to 180 degrees to help us find the measure of the missing angle. We find that angle C equals 65 degrees. Next, we use the law of sines to find the missing side lengths. Sine of A over A equals sine of C over C. Substituting the values we know, we get sine of 62 over A equals sine of 65 over 5. By solving the resulting equation, we see that A equals 5 sine of 62 divided by sine of 65. Plugging this into our calculator, we see that the length of side A is approximately 4.9 units. We can repeat this using sine of B over B equals sine of C over C, and we find that the length of B is approximately 4.4 units. The law of sines can be used to solve a triangle when given the measures of two angles and the included side, angle side angle, ASA, or when given side angle angle, SAA. When given side side angle, SSA, this is called the ambiguous case. This is called the ambiguous case because given this information, 0, 1, or 2 triangles are possible. We will discuss more on the ambiguous case in our next lesson.